Hi there. Welcome to another episode of AI Champions Hub, where we try to learn about data and AI and kickstart the journey or enhance your current knowledge, and where I share my experiences and so on. And particularly this channel is meant for no code type of approach, this particular series of recordings. I do record with coding and a lot of technical heavy lifting, but here in this series you will see that it's more about getting you started with the core concepts and application to business so that it's directly impactful. Okay, all right, let's get started. Today's topic is going to be very interesting because we are going to be looking at how we can quickly get to know about our data, right? So we all know, we all have data that we are working on. So you could be a working professional, business analyst, or somebody helping your business in some manner, right? And we time to time get data, and one of the first steps we want to know is how can I make sense of this data, what can I do with it, and so on and so forth. So that's a common challenge we have, and we're going to see how we can get started in that space. And this is literally sort of the first step in many ways to get going on the data front. Okay, so here I have a sample file, and it's got height and weight, and if you look at it, I'll give you the Excel sheet and I'm going to attach it as part of the YouTube recording. But as you can see, right, I have about, let's say 88 type of values. These are heights and weights. So for a height of and these are of students or somebody has collected data around teens or students and so on. So if I look at for a height of 5, there's a corresponding weight of 50 for somebody, right? But there could be another person closer to 5 and their weight can be around 55 or something like that, right? Now as you can see, it's spread out, it's all a little bit all over the place in some manner, right? So how do I make something out of this, make sense out of this data, right? So it could be sales and impact of something on sales and margin or something like that, right? It could be any data you have. So when you have such data and all you have is the data, how do you make sense of this, right? So I wanted you to pause this video for a minute, just think through as you're looking at this data set, what do you conclude, what do you draw out of it? Are there any knowledge, insights, something that you're able to draw? And I just pasted more of this so that it's easy for you, it's in one screen. So just pause the video for a minute and have a look at it, okay? Now as we go about these things, right, so we know that as the number of records get larger and larger, it becomes difficult for us to comprehend what's in the data, right? We want to be able to quickly understand in a summary fashion what's in the data, what's the data telling me, and then therefore what actions can I take on the back of it, or how can I go about leveraging this, right? So that's sort of the endeavor. Now that's where descriptive statistics comes to our rescue, right? So we will be learning about descriptive statistics, very valuable in terms of quickly understanding data. So that's where the lesson is, and be with me till the end so that you can get a sense of how this can be done, right? Now statistics is per se, it's all about learning about the data. It's about studying the data, getting a quick sense of what it is, right? So that's in a simple sense. My approach is to keep it simple. While I give you the definitions that are available, it's simplicity that will help us, right? So how can I learn quickly about data? And that's the field of statistics that's going to help me there, right? It helps us with the discovery process, getting the knowledge, and so on and so forth. And therefore the models that we build with statistics, right? Models are nothing but, think of them as functions in a mathematical sense, and the functions that we build are to allow us to help with predicting something of future. So I know something about the past, I want to predict the future. So if a new person comes in, what could be his weight? given a particular height, given this data set, right? So that could be a prediction. Similarly, inferences. So what can I draw out of this data, right? And now from a business standpoint, and then therefore I can take action, okay? So that from a statistics standpoint. Now descriptive statistics is one of the subfields, and you will see that that's one of the starting points for many of us from a statistics standpoint. And now if I want to analyze height and weight and the combination, so there are certain techniques that are available. So let's look at the techniques that are available for us as we go along. So univariate analysis is analyzing one particular variable. So if in this case either I'm only looking at, let's say, height alone and then trying to see what's the kind of distribution, what are the height compositions of this sample or the population of sample of students that I've taken data from, right? So that is univariate analysis. So and then bivariate is if I'm looking at two variables in combination together, like height and weight, I want to know the relationship between them. I want to know how is there some correlation between them and so on. That's bivariate. And then multivariate is, extending it further to many variables and so on. So if you look at it, the univariate analysis, there are three techniques that are easily available for us. So let's zoom in on the techniques. So measure of central tendency is summarizing the data such that we can understand where the data converges primarily, right? In a loose sense, that's what I say. So there are three measures that are available to us. So if you look at mean is nothing but we all would have heard about average. So it's a sum of all the values divided by the number of these values and so on, right? So in this case, if I total all the height and then divide it by, I think 88 values, whatever the number of values are, 88, then what is the average value, average weight that I get? And similarly for height and so on. Median is a number that divides the data set into two equal halves. So that way, when the data is ordered, what is the number that's going to divide the data into two halves, to the left and the right, so to speak, right, in a graphical sense. So median will tell us where the data splits into half, and then therefore how we can use that knowledge, right? Mode is what is the most frequently occurring value. So if most of the data points are around, let's say, height of 5, we can say that, hey, mostly the values are around 5, and that's where the observation of mode can come. Okay, so that is about central tendency. Mean, median, mode help us understand quickly in a numeric fashion what these numbers are. Now together they add quite a bit of value as well, right? So let's look at one other concept, which is outlier. Now outliers can be extreme values which may be important, may not be important, you can't ignore them, but they are values that you may want to specially treat, right? So in this case, let's say for example, on an average we're looking at a height of folks to be between, let's say, 4.5 and 5.5 feet, right? Now doesn't mean that everybody is going to fall in this bucket. Now there could be some who are, let's say, 6 feet 5 or 7. Now if I've taken this data for school kids or college kids and so on, then it's highly unlikely that there will be many who are in the 7 feet range or something like that. So then 7 could become an outlier. There could be 1 or 2 students or members who could fall in that number, right? But that's going to be rare, right? So but nonetheless that's possible. So that's an outlier for you. So a mean is sensitive to the outlier, right? So if let's say we say average height is 5 feet. Now if I add an outlier to this, right, like a 6 or some other number to the left, just to keep the counts even, so you will see that the mean will get literally affected by the outlier, because if suddenly you have somebody coming in with a height of 7, now my average will shift to something like 5.5 or 5.2 or something like that, right, depending on the data set that we're looking at. So it will shift to something closer to the outlier. But then the median is not going to be affected too much by the outlier values suddenly by adding an outlier to this, because it's splitting the data into equal halves. It doesn't care what these values are. It's as long as they are there, for all you know, all the values could be the same. and then the median is literally you're just aligning all the data set and then splitting the at the middle. So there you get the gist of it. So when I look at it in the combination, so I know where the numbers are and so on and so forth. Now let's look at these other measures, and they will also help us get a sense of this data, right? Now there's a second concept called how much is the variability. We partially looked at it. So a range is giving me the max and the minimum difference between the two, right? So if I take the max and the min, so let's say my maximum value is 5.5, minimum is 4.5, my range is going to be about a feet, right? Now if I look at, if my values are very dispersed, then let's say I have values in the range of 7, and then I also have values in the range of 3 feet and 4 feet and so on. That means my data is spread out. My average could still be 5, but my data is spread out because I have a range of values that are coming in, right? People with range of heights. So that means this variability is very high. It's not homogeneous and it's not nicely laid out at the middle of the data set, but it's spread out. So that's what we try to understand based on measures of dispersion. So range is one of those values that will give us this. Then we have variance and standard deviation. Now standard deviation and variance are related. Variance is the squared value of these differences, and therefore it allows us to scale difference, so to speak. It will allow us to quickly understand what is the degree of the variability, and then standard deviation is the square root of that, and it will help us quickly look at a single number in that sense, because squared values are a little difficult for us to comprehend from a Newman standpoint. So standard deviation is the square root of variance, and we can quickly understand what is the degree of variation, right? It tells me how my values are, how far are they from the mean, right? When I take a look at when I compare it to like a normal distribution, which is the reference in many of these statistical areas, right? So if I look at 1 deviation, 2 deviation, 3 deviations, how many of my population or sample values fall in this category, right? So standard deviation will quickly help us say, hey, 80% of my values are within this plus or minus 2 deviations or so on and so forth, right? So then you get a sense that, hey, most of my values are again not varying, or they're varying, or whatever it is, right? So that's the part. Now let's look at the third part. So we looked at where the values converge, we looked at the variability. Now let's look at the shape of the distribution itself, right? Now skewness is something that indicates whether my values more closer to the lower end of the spectrum or more closer to the higher end of the spectrum, or is it equally distributed or more closer to the middle, right? So if you look at, I've drawn some graphs here, so you will look at skewness. So skewness is literally telling us, so if it's normal, then that means all the values are nicely laid out. I have equal number of values to the left and right of the median, and so on and so forth. Now if it's positively skewed, that means most of the values are closer to the lower end of the spectrum and away from the mean, and the degree of the distance from the mean is given by the measures of variability that we saw already. But skewness will indicate, whether I am away from the mean to the left or the right? So that's what you will see here. Then we have another measure which is saying, hey, what is the level of peakness, so to speak, right? So this is the bell curve. When you plot all these values, you will get a distribution of some of this, and we will see these in terms of histogram or so on. So kurtosis will tell us how is the value peaking more to the center, or is it, if it's too dispersed, then it will not be peaking to the center, it will be less below the normal peak of a normal curve, okay? So kurtosis also gives us a sense of the peakness. Skewed value, skewness gives us a sense of how close am I away towards one end of the spectrum, or away to the other end of the spectrum, or am I close to the middle, and so on and so forth, okay? Alright, now let's look at it. Now that you have learned the concepts, let's move to the next section where we are able to now quickly, without coding, get a sense of how this is and get this going. Now I use a tool called KNIME, and KNIME is a wonderful tool from a learning standpoint, and also in terms of being able to use it. So you can go to, if you're getting started, if you're not familiar with the tool, just go to knime.com, and Knime is Knime, that's how it's spelled, and you will see that you can quickly look at it. You will see that many companies are using Knime. It's one of the UI based tools. There are others available, but for learning you can easily get started with Knime. It's quite easy to get going. So you can download the software, be it Windows or Linux, whatnot. So you can just go and see what it is, fill your registration, and so on and so forth. Now, so that's how you get started. One other step you need to do is you need to specify as you're installing, where are you going to keep your, so what you build in Knime is what is called as a workflow. Now these workflows are taking an input, taking them through a set of steps or transformations or changes and so on, or calculations and others, and then finally you may get an output or a prediction or a model, right? And so this workflow is UI based and so on, and you want to indicate where are you going to keep these workflows, right? Where are these objects going to sit? So in my case, I've indicated that, hey, Knime is here, and then I'm putting this in a workspace. So all you have to do is indicate the workspace. I have many of these workflows here, so I just indicate that, right? So those are the two key steps that you want to do just to get started. Install, indicate the name of the workspace, and then just get going. So here what we can do is, if I go to home, you will see that there is options to either create a new workflow. If you already have, there are some sample workflows that come with the package. You can open them and look at it and go with that. So I'm going to just simply create like a simple workflow for you. I already created a workflow, but let's say for example there are, okay, so these are updates. It's indicating, give me 1 second, I'm not sure why this is a little slow here, but if you click on it, you will be able to get a new workflow. You can get going on a new workflow. Yeah, there it is, right? Now one of the first steps is, so now the file we have is a CSV file. If you look at it, so where I have placed it is your YouTube learnings, and I'm specifically placing it here. So I have this file which is a CSV comma separated value, and it's called height and weight and so on. So now if I want to, first thing is to obviously read the file, bring it into the package, and that can be done with a CSV reader. So depending on the file format, you may want to say, hey look, I will use CSV reader or CSV writer or whatever it is. So these are called widgets. So I can quickly search on the type of widget I need. So there are various types if you look at it. There's manipulation, there's views, there's analytical ones, there are database ones, and so on and so forth. Okay, depending on your need, you can put the widget, connect them, and go with it. So here, first thing is, I have a couple of things here. So there is a config piece of it where I can set the values for a particular widget. I'll show that in a minute. Then the execution part is clear. So if I click, once I've set the configuration, like in this case, if I've indicated where the file is and so on, I can go and execute it. I can stop, cancel, and so on and so forth, right? I can do all of that. And you have the entire workflow if you would have executed it partially and so on. But let's say you want to reset and start from the beginning, the reset options can do that. So it will reset this, so you can execute it again and refresh the values. And the bottom, you will see the progress of these, right? So now this specifies whether something has been run or not. So once you have successfully run this widget and the node, the value will turn to green, and you know that there is something. Then I can go and look at the outcome of this widget. Okay, so it's as simple as that. Now let's go and look at the config that are available for the CSV reader. Now all it's asking me is go let me know where the file is. So I could go and point to our if you look at it, we had put this where is our friend, Knime software, workspace, YouTube learnings, and so on and so forth, right? I keep moving files here and there, so you won't see many of them there. Okay, all right. So now if you look at it, now I've read the file, the widget has read the file, and it's clearly indicating that there are two columns, height and weight, and these are some options. So if it's a comma separated, I can say, hey, this is like a character that's separating them. There's a line break in this row, and so on and so forth. You can set all these values. I don't want to overload you with all of these options at this point. Just go with the default for now. The two things I would say is, you have to indicate whether there's a column header in the file or not. Sometimes the files may not have a header, so you indicate the column header and then the other piece is row number. So if in the file, for example, I had a customer ID or a student ID or whatnot, so those are, they are already indicating each of these rows as a unique value, right? So if I had such a thing, then I could have indicated that, say, hey, one of my first columns, usually it's the first column, so one of my first column is a row ID, and automatically this widget will read that as a row ID, right? And row ID is something to identify the values uniquely as we are processing this data set and working through this data set. If I don't have anything in the file which is indicative of which students and so on, let's say for privacy reasons you're not bringing customer details and so on, you just are interested in transactions and the relationship, and it could be similar thing, it's just product and sales and those kind of things, and you can then generate, the tool will generate a running number and a row ID and so on. Okay, alright, so that's how you look at a widget. It's got config, so there are various tabs. You can indicate what is the data type, you can have advanced settings and so on and so forth. So in this video we are more focusing on the process and the cycle. I will do a separate video if required, if that's of interest, to show what are the other tabs and all that, and this will differ by the nature of the widget. So here we are reading the data, so it's giving you all the options related to, should I skip the first file, should I skip the row, and all of these things. Okay, alright, so that's one of the widgets. So now I have already created what is called as a workflow. Now NIME is again another tool which allows us to document things while we are doing XYZ. So if I just right click on it, I'll say hey, new annotation, and I can say XYZ, whatever it is. As simple as that, right? You can put your text, you can put the steps, you can group these widgets into something nice so that you're sharing with somebody and you can use it. Okay, alright, so now let's do this. I've done the same thing, the values are same, indicated, it's basically reading this file from somewhere, and then I've done the same part of it. So okay, now that I've read the values, so I have read the values, they're available, height and weight here, I've already executed them. Okay, now I want to look at the measures of central tendency, whatever we have learned, right? So now we want to look at statistics. So statistics widget will allow us to do that, and it will clearly indicate what is it that, which column are you trying to look at, or which attribute you are trying to analyze, and so on and so forth. So I have 5, 10, 20 of these values. I may be interested in just analyzing weight, height for a minute, and then something else and all that stuff, right? Now the tool allows us to generate a histogram of those values and so on, and we'll see that in a minute, but the basic statistics are available, and then I can start looking at it, right? Now how do I look at the statistics? If you click on it, so you will see that this particular statistic widget has 3 kind of outputs. It's got a histogram table and occurrences. So let's just quickly look at these values. So the statistics table, that is giving me the basic statistics, minimum, maximum, mean, standard deviation. We'll look at it in a minute in a different view, but that's something quickly available. Then I can look at if there are nominal values, the nominal value histogram that are available, and then there is occurrence tables that are there around that, the frequency of this and so on and so forth. Okay, so if I think if I reset and execute it, I can get that. Okay, so we are interested in the basic statistics. So if you right click on this, so all I did is right click and then do a open view, you will get this kind of a visual, and then you can start playing with it, take a screenshot or work on it, right, and stuff like that. So here this is a similar visual of the statistics. I get to see the minimum and the maximum, so that gives me the range, saying hey, height falls between 4.41 and 5.41, but roughly a feet of difference. But then when I look at weight, is spreading between from 31 kilos to 82 kilos and so on and so forth. So there's a wider spread and so on and so forth, right? And then I can see the mean value, the median, skewness, kurtosis, and all of these things are there, and then I get a quick sense of the histogram that is available with me. Okay, now let's look at another widget, which and then we can do the analysis on the back of that. So there is a data explorer which will allow us to do little more interactive pieces. So if you can search here, you can search on data explorer like statistics, you can search on this and you will get these values. Okay, So there are a lot of visualization options and other things available so for you to work on. Now if I look at data, again similar to the statistics one, just right click, you will be able to open view, and there I can see this nice summary of this in our data explorer. Now not only that, right, so here if I look at it, I can see the full histogram in a proper manner. I can see those values as well, and so on and so forth. So minimum, maximum is given, skewness, kurtosis, all these are available, and then I can see the histogram is nothing but a count of values falling within a set of intervals, right? So in this case we are looking at height in feet, so every 0.1 interval the values are counted. So that means between 4.8 and 4.9 there are 16 members. Again likewise between 4.9 and 5 there are 16 members, and so on and so forth. So that's the histogram quickly lets us know where the counts are. That means there are more people in the center, there are very few on the side and the extremes, and so on and so forth, right? And that is also indicated by your variance and the standard distribution elements that will tell us that it's the variance is not very high, so therefore you will not have to worry too much about it. And also the skewness, right? Now I see the values are sort of equally spread. They're not tilted towards one extreme or the other, so the skewness part of it is something that will also be indicated. Now let's look at weight in a similar manner. So weight is slightly different. If you look at the histogram, as you can see, right, you can pause and do an analysis for yourself as well. Pause the video and look at the analysis, and then you can come back to this. So what we see here is a lot of weights are more towards lower end of the spectrum, and very few people are closer to the 80 range. Of course our range of weight itself is very wide. So the lowest value is 31, highest value is 82, as you can see from the minimum, maximum. My average is 48, but the variation is quite high. I can see that in with the variance values and so on. And also the skewness is positive, right? So it's indicating that my values are more closer to the lower end of the spectrum. And yes, there are some values in the higher end of the spectrum, but they are very less, right? And there's a tail of some kind that you will hear these terms as you learn more about statistics and so on. So there you have it. It shows me the skewness. I see that weights are slightly different, and then heights are distributed in a certain manner. Obviously, when we look at the relationship between height and weight, we can easily make a sense that they are not necessarily one-to-one correlated. Obviously, the graph themselves are not indicating that, right? So whatever is maybe the height, my weights are more closer to lower end of the spectrum from a height standpoint. And then now we will, of course you can't conclude anything by this, so then we will do the bivariate analysis, but you can get a rough sense of saying, hey, if most of my values are closer to 4.9 here, and then most of my means are from a weight standpoint are closer to mean is around 12 or something like that, right? I think or 48, right? So what could be sort of the relationship and so on and so forth we can look at, right? So that's part of your bivariate analysis and so on and so forth. Okay, now let's look at a little bit of this part in terms of bivariate analysis, and I will try and do a separate visual from that standpoint, but now that you're in the video, let's look at it quickly. So bivariate, I can either do a quick correlation analysis, and the simplest would be plot the values and see if there is some relationship that comes up. Scatter plot is a very good tool. Sometimes you don't need to know the fancy things, but just know the basics, and you will see analyzing the scatter plot gives us good indication of whether there is a correlation between height and weight. There is also a numeric element to it. That correlation coefficient will be able to get us the numeric indication of whether it's positive correlated or negatively correlated. How is that correlation, right? And then the relationship, obviously some of you might have heard of terms like regression. Now regression is a classic, it's a wide topic, but it gives us a good, end of the day I get an equation saying, hey, between the input and the output, this is the nature of the relationship. It's defined by this function, which could be like AX plus B type of a relationship if it's linear. If it's non-linear, it could be something else, and so on and so forth. So regression is another way for me to analyze relationship between two variables, let's say X and Y, and so on. Now, so there are a lot of widgets available here where I can look at correlations and then the correlation coefficient and values like that, right? So here I'm saying, hey, look at the correlation between height and weight and include both of them, right? Now, if I look at the values here, so you will see that correlation values indicated at the bottom. That is just a number, and it tells me that there's a positive correlation. It's not 100, so if it's 1. So if it's closer to, if it's 1, that means there's a perfect correlation. Every time weight increases by one small unit, height increases by one small unit, you can see a corresponding weight increase of one same 1 unit, right? That kind of a relationship is a perfect correlation, right? Or if it could be the other way, negative correlation as well. But in this case, we are looking at a correlation of 0.705. That means they're not perfectly correlated, but there is a correlation, and weight and height do increase, but maybe they increase in step, maybe they increase in for a given set of values by a certain degree, right? Now, like I said, visuals are an excellent way of quickly getting the sense of it. So we look at the scatter plot. There are various scatter plot widgets available. You can plot them and check. So you can see quickly that, and there are a lot of options to play with it in terms of, like, coloring and so on and so forth, and all of these. So now all I'm doing is plotting weight and height as they're appearing as a data point. So they are occurring together in the rows, right? So now these points are now nothing but they're indicating the intersection of weight and height when I plot them on a simple graph, right? So as you can see, right, there is some correlation because it's linear, the values increase, but then the values don't necessarily increase in linear sense. So let's say, for example, I take a height of 5, I have somebody with a weight of 40, 42, I also have somebody with a weight of 68, right? So it doesn't, there's no definitive X to Y type of relationship here. There is some degree of relationship. That is to say, hey, if my height goes to 5.10, 5.15, right, so or 5.20, let's just take 5.20, you will say that correspondingly my weight range also increases. So my minimum weight in that or minimum values that I can observe is about 46. That has gone up, right, relative to this value which is around 40, and then maybe my higher values closer to 64 or something like that. So there is a corresponding increase, right? So as height increases, yes, weight also seem to be increasing, but that is not consistently observed across all the values. There is some degree of dispersion or variability within these ranges, so to speak, right? So that is a good way of quickly analyzing, saying, hey, what is the relationship between height and weight? And I can say now, okay, looks like there is some relationship, but not. Let me go and find out what is the degree and where is the sweet spot. And whatever your directed objective is, you can go and work on it, okay? Alright, so there you have it. You've learned about, we took a data set, we went and said, hey, what kind of questions can I answer? Can I learn something about the data? And that's where statistics comes to your rescue. We talked about central tendency, mean, median, mode to help us there. We talked about the variability with range, standard deviation, variance, skewness and kurtosis that give us the degree of closeness to one extreme or the other, and then the peakness of the value, which is kurtosis, right? And then when we talk about bivariate analysis, we said how we can understand the relationship using correlation analysis, scatter plots, and then I will do another video on regression. How do we start going with regression? So regression will give us an exact equation which tells me what is the degree of height to weight relationship. Till now, you've just seen the directional indication with correlation or scatter plot. With regression, I can get a definitive equation and all that. Okay. If you like this video and you learned something, just do send your feedback. Subscribe to the channel. Looking forward to your comments, and happy to see you in the next video. Thank you very much. Bye bye.